In my last tutorial, we inserted 4 plane definition in my structural model. In this tutorial, I'm going to show you how to specify the Z value for each of the plane definition. So I'll click on the P1 plane definition label on my structural view 3 on the left hand side of my screen. I'll right click on it, click on property. You will see this the property dialog box will appear. Um, I'll close this first. I'll close this. I will reopen it later. I want to uh, before you change your Z value for each plane definition, you have to note where your points are located for each of the plane. This is my P1 plane, and my Z. I have a Z value here, 0.3 here. Don't 0.3 is here. 0.3 is here. There's any point here. If there's any point here, that means my 0.1 and my 0.2 is are at the other grid at grid line B. So 0.3 is here, 0.1 and 2 is along the line B. So if I should move to my AutoCAD drawing, you will see that on my roof lodging arrangement for the section KK, this is the section. I want to slope my roof from left to right. If I should draw a line from this point, an horizontal line, actually, this line represents my plane that has been inserted on Orion 18. What I'm trying to do, I'm trying to rotate that plane. I'm trying to, let's say, this is my plane in Orion 18. This is my P1 plane. I'm trying to move this point upward. So it means that from this illustration, this point here is the elevation at this point is Z equals to 0. The elevation at this point is my Z value, which I want to move my element to. So I need to measure the distance from this point to the top of this beam. So to do that, you use the measure command. If I use the measure command, the value is 354, 354.25, but I will use 355. I don't like using the decimal value. It's not professional. Yeah, we should work in 5 mm for every 5. You should work within the limit of 5 mm, 10 mm, 15 mm, like that. So 355 will be my Z value. You can get this value by actually also deducting this elevation from this elevation. So if I should use my calculator tool, you see 118,780, which is this elevation, minus 18,425. This is 355. So my elevation difference is 355. So I want to move my floor 355 upward. So to do that, means that this plane definition 1, I want to move this edge at B 355 upward, and at the line B, 0.1 and 2 are located along that grid. So I'm going to move that point. I'm going to change the Z value of those 2 points to 355. So I click on P1 property. My Z1, this is 0.1, Z1, raise it up 355, positive 355, 0.2, raise it up 355. My 0.3 will be 0. And because it's located along the line A, I don't want the elevation to change, so I'll leave it at 0. I will update. So I've updated that plane now. So to move my member to the new plane definition, I'll click on P1, I'll right click, and I'll move member to plane definition. You will see the change. You can see now my beams, my column, and my slab has been raised up by 355. Now we'll look at the plane definition 2. The plane definition 2 is bounded between B and C. At B, we have green line 3 there. Remember, here we have 2 points here, 2 and 3. Actually, this 2 is for the plane definition 2. While 3, I'm thinking is for 3 will be for 3 is the point for plane definition 2. So if we have plane definition, if we have 0.3 here, that means our other 2 points are along the line C. So we have our Z value here, our 0.1 here, and we should also have our point 2 here. The 3 is for this plain definition 4. So I have my Z value as 3 here. I have my point for this plain definition 2, I have a point 3 along the line B and point 1 and 2 along the line C. So I will click on plain definition 2. I click on it, click property. So point 3. So before I specify the Z value, I would like to explain something to you. In my AutoCAD drawing, I just made drawing, the section drawing for the floor. I've told you that this point here, this elevation of the roof 18425, which is Z equals to 0. I've shown you that this point is Z equals to 355. What is this point here? To get this elevation here, the elevation here will be the Z value here will be this elevation minus this elevation. I use my calculator. So 18848. Sorry, 18848 minus this elevation here, 18425. So the elevation is 423. So you should know that my Z value here is 423, and we have already calculated our Z value for B to be 355. So this is for B, the Z value is 355. For C, the Z value is 423. So I'm going to apply that to my plain definition now. I told that B, we only have a 0.3 there. So 0.3, I will set the value to 355. 0.1 and 0.2 will be 4. I've forgotten the value. Where's my calculator? Be 423. So 0.1 will be 423. 0.2 will also be 423. And I will update. I've updated my plain definition. Now I will move my member to the plain definition. Move member to plain definition. Once you do that, now you can see that the slope is subtle, but the member has moved. You can see the slope. This beam is sloped, this beam is also sloped. Now we have to deal with plain definition 3 and 4. I'll deal with plain definition 3 first. Our Z value for C, we say is 423, Abi, 423. Our Z value for D, we'll go to our drawing and we'll determine the value for D. This is line E, this is line D. So our Z value for D will be the elevation here minus this elevation. So I'll use my calculator on my laptop. The elevation at D, which is 19060, minus the elevation of the floor, which is 18425 at the line A, 18425. So this is 635. So I have 635 here. I have 635 here, and I have 423 here. 635. So I will go to my Orion model. So on my Orion model, for the P3, my point 3 is at this point. So if point 3 is at this point, means point 1 and point 2 are at the other point. So my point 1 and point 2 elevation will be 635. So I'm going to click on the P3 label in my structural view tree. Click on it, click property, my 1 and 2, 635, 635, 635, 635, and my point 3 will be 423. The elevation at the line C, 423. I will update, and I will also move my members to the P3 plain definition. So you will see that the members there has been moved. You can see the inclined nature of the member at this point. The base beam is inclined now. For the last plain definition, we say the at the line C, the elevation is 423, but at the line E, I'll go to my AutoCAD drawing, at the line E. So this is the elevation here. Subtract this elevation from this base elevation here. So if I use my calculator here too, we have 19119 minus 18425. So this is 694. So that means at the line E, the elevation is 694. So I will move to my Orion model. We have 1 and 2 at E. We have 1 and 2 at E. So that means our point 3 is at C. So I'll click on P4 property. Sorry, I want to check my calculator again. What did I just calculate? Sorry. Can't remember what I just calculated. Sorry. So 19119 minus 18425. This is 694. So 694, I enter 694 as my point 1 and point 2 value. 694, 694, and the point 3 will be, I think, 423, but I'm not sure. That is the line C. Let me calculate it quickly. 18848 minus 18425, 423. So my P3 will be 423. So I will move my member to that plane definition, and I will show you my 3D view. What happened? You need to check that plane definition again to know what is going on. The elevation dropped instead of increasing. So sorry, my P4. Sorry, this is slap by dialog box. I'll pick the P4 from here. Property. The point P1 and P2 694. And our Z3 423 is okay. I wonder why. Let me move member to the plane definition again. Okay, it actually looks okay now. Okay, it's not okay now. So it's not okay. It's now you can see my roof is now sloped. So it's now sloped at 5% to the roof gutter. So we have come to the end of this tutorial. We have sloped our slab elements on the roof. In my next tutorial, we'll make some little edits to our drawing before we run the analysis, structural analysis on the on this Orion 18 software. Thank you for watching the video.